Hello friends, our next DSA question is search a 2D matrix. So you have given a description. You have given n by n integer matrix with the following two properties. So we have given a matrix that is m by n. So m means row, n means column, and with the integer matrix. So each row is sorted in non-decreasing order. It means each row is in increasing order. So if you see the first example, 1, 3, 5, 7, it is in increasing order. The first integer of each row is greater than the last integer of the previous row. That means if you see the first integer of each row, that means if you see the first integer of 10 of second row and the last integer of the previous row is greater. So that means if 10 is greater than 7. So if you see these all are in increasing order. If you see the zigzag line. So 1, 3, 5, 7, 10, 11, 16, 20. Same with the 20, 30, 23, 30, 34, 60. So this is the you have given a constraint that is the description. So given an integer target, you are also given a target. You have to return the true if target is in the matrix. So if a target is present in the matrix, you have to return the true. And if we are not able to what we say not able to get the target, you have to return false. And you have to write the solution in log of m into n time complexity. So that is the thing we have to use to solve this question. So time complexity is log of m into n. So we are going to solve in two point with using two pointer technique. So that will be solve this problem. And the example is the first example is 1, 3, 5, 7, 10, 11, 16, 20, 23, 30, 34, 60. This is our given matrix. We have to find the targeted value, that is targeted value is given 3. So we have to find that. So 3 is present in the matrix, so we have to return true. And for second example, 1, 3, 5, 7 with the same example, and the targeted value is 13. That is not present in the matrix. If you see, that is not present in the matrix, so that is why we have to return false. So constraints are m equal to matrix dot length. So m is the matrix dot length, that is the row length. N is the column length. So we have to consider that. And the length of the matrices is 1 to 100, in between 1 to 100. And the element present in the matrix is minus 10 to the power 4 to the uh, is sorry minus 10 to the power 4 less than or equal to matrix of I of j. So that means it is greater than or equal to. So it is greater than or equal to minus 10 to the power 4. Our target is less than or equal to 10 to the power 4. That means target is less than or equal to 10 to the power 4, which is less than or 10 to the power 4. So we have to consider this constraint to do to solve this question. So if you see that we have to use two pointer technique. So I am going to start with the first. So I'm going to take one pointer that is from 0. That is from starting from 0. So this will start from 0. And int of j, I'm going to start at matrix of 0 dot length minus 1. So that will start the matrix of 0 of length minus 1. So length of the first matrix is 0. So row is 0. And we will start the position of this point. So length is 1, 0, 1, 2, 3, 4. So length is 4. So we have to start from this and we will complete this by reducing the element. And if you we will check that one by one element. If this element is present in this row, so we don't get we don't have to go to the next row directly. Just we have to return the true. So first of all, I will check that while if I will increment, we have to increment up to the length. So that is why I am going to give the condition that is less than matrix dot length, and if you give equal to, so we have to subtract 1, so that is the condition here. And I also going to check the j value. So if I decrementing the value, so that value is not able to go beyond the 0, so it will go beyond the 0, so where there is no element, and it will give the error. So that is why we have to use j less than or equal to 0. So that will, oh sorry, greater than or equal to 0. So it will check the value is j is greater than or equal to 0, and we have to do that. So first I will check that if matrix of I and j are equal to target. If that is the case, so our result is going to be true. So I am directly returning true. And if else if, so matrix of I and j is less than target. So that means my matrix of I is less than our target. So if matrix my value is less, so that means I have to increment the j, because in increasing order we have to check that also, because this is in increasing order. So I have to directly what we can say, I have to increment the row, because if we my value is 11 and our matrix value is 7, if this is in the position, and we don't have to decrement the j, because there is no value that is the greater than 7. So I have to directly shift to the next row, and I have to decrement the j. That is, I have to check the value present in the next row. So that is why I have to increment directly I. And if that is not a case, that means if my matrix of I of j is greater than target. That means if you see the I want to I have target 3 and my value is 7, and I have to check in the same row, so I have to decrement the j, and I will check the element in the that row. So I have to just decrement the j, and if this condition is not fulfilled, that means all the element I have checked that all element are not equal to the target. So I have to directly return false, because there is no element present in the matrix. So I have to directly return false. And if you check the result, so just give me, it will take time because I am using the recorder. That's why it will take time. Yes, we are getting the result. So just give me. So if you see the all the test cases are passing, and here I am using time complexity of log of m by m into n, or which is less than this time complexity. I am using two pointer technique. So which is what we say same with this time complexity. So here we can see the time complexity is same, and we are not using extra space. Here we are using just constant. So O of 1 is the time complexity. So so right now I'm going to submit the result. Just to give me a second. Yes. So we got all test cases accepted. So thank you.